So we've mentioned, we've got blasts, we've got sites. Now we're going to see that we've got the class, okay? And then I'm going to have one that I'm going to introduce to you later on in the chapter. We're just not going to talk about it right now. And one of the things that we have identified is that bone tissue is dynamic, meaning it is going to build up, it's going to break down, it's going to renew, it's going to heal, it's going to have all these properties that we think about can happen within the body. Now, cartilage, which is a part of this system, cartilage doesn't have that ability, okay? However, cartilage is our backbone for the skeletal system, okay? So cartilage is important. Now, we're going to see what happens with the cartilage, how we're going to see it develop into bone. So I want us to really try to have a good understanding of these particular cells. So this video right here, now I'll go ahead and let you know right now that the music on it is very cheesy. I have no idea who got to be the music person for the video. However, it's talking to us about blasts and clasts, okay? Of the three that we have talked about, it's missing the site, all right? Now, the blast does what?
Gives rise to.
Okay, it's going to give rise to, and now that we're talking about connective tissue, we're talking about having the matrix. So that blast lays down the matrix. Does everybody remember that? Okay. And then once the blast gets stuck in the matrix, that's when it becomes the site. Does everybody remember that? And then what's the job of a clast? To break it down. So the two that are going to be shown, okay? The one that lays down the matrix, one that's going to break it down. Okay? And like I said, very cheesy music.
Bone is a dynamic tissue that is continually being built, broken down, and rebuilt in a process called bone remodeling. Bone tissue is broken down and resorbed by multinucleated cells known as osteoclasts. These cells are derived from monocytes, which originate within bone marrow. Osteoclasts play an important role in liberating minerals and other molecules stored within the bone matrix. Bone tissue serves as a repository for vital minerals, including calcium phosphate and various biologically active molecules, such as growth factors. The release of calcium from the bone can play a role in maintaining its homeostasis within the body.
Guess what this part is? Which fiber? Which one is needed for being the rebar? Because this is our concrete and this is our rebar. What fiber is this? Collagen. Okay, collagen is the toughest, okay? And so remember how I said it was going to look like it doesn't have a hole, but that's our rebar. And then what's this right here? What's our cement? Think about eating.
Calcium.
Well, What's another, how did I say to say it? It's not spelled like having an appetite. This is our hydroxyapatite, the calcium phosphate. Okay, so this is the cement, this is the rebar, the collagen, and then the calcium phosphate. Does that make sense now?
The cells responsible for building new bone tissue are known as osteoblasts. Osteoblasts are thought to be derived from cells found to be associated with blood vessels. Once active, they start to produce the organic component of bone, osteo, which is predominantly made of collagen. Minerals start to crystallize around the collagen scaffold to form hydroxyapatite, the major inorganic constituent of bone, which contains calcium phosphate. Bone mineral density, or BMD, can be used to estimate the strength of bone and to assess the risk of fracture. As osteoblasts form new bone tissue, many become embedded within the matrix and differentiate into osteocytes.
Oh, they didn't.
The structure, composition, and cellular processes that occur within bone allow it to simultaneously serve as a calcium reservoir, while providing structural support for the vital organs and for locomotion.
So like I said, kind of, cheesy on the music and everything, but hopefully that kind of gives you an idea about what we're going to talk about, what we're going to discuss. So, this is the point that we left off on Thursday, and I think I was trying to point out a major difference about the connection between the cells in the bone's matrix. And did we talk about them being or having that connection one cell to the next? One cell? Okay. Well, the process that's occurring is called ossification, okay, the hardening, okay? Now, when we look at bone, and if we're noticing that this, okay, this osteoblast laying down the matrix, it's going to get stuck, okay, in the matrix that it lays down. And it's going to then become the osteocyte. So if we look at this, and if we see that we're going to have this connection where we're going to see osteocyte, 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 okay? Those have these projections that are extending off. These extensions are the canaliculi, okay? So one of them is going to be a canaliculus, all right? All together, all of these extensions that are moving off of that site, these are our canaliculi. So we now have that osteocyte stuck in its lacuna and these projections. Now look at this up here. What do we see occurring with those projections? They have a connection. We now have a connection from one cell to the next. So we now have this communication that is existing from one site to another site, to another site, to another site. Okay, is everybody with me? Why? transfer, exchange, what? What? We got nutrients, we've got waste. Wait a minute. Bone dynamic. Build up, break down, remodel, renew. What else does it have? Blood supply. All right. Makes it interesting. The first, one of the times that I held this up like this, I had a student in the class. I was like, okay, what is this? And he goes, a Madonna outfit. No. Okay, not that. All right. So I have to be careful how I carry these now. Okay? Because I really did not have, my mind go there. But hey, all right. Now, trying to figure out a way that I can set this up and do it on camera because my online students need to know this too. Is it showing? You can do this one. Maybe the one this one. It's just such a pain. All right. Boom. So basically, what I'm going to have here for these, okay, think about taking a piece of this, okay, and we've made our sectional cut, okay, and we're now looking into that bone. Is everybody with me? All right, so, boom. What we're going to notice, okay, the sites. We're going to talk about what happens with these materials that are going to be able to pass, okay?